In this video, we're going to take a look at an introduction to trigonometry and SOHCAHTOA. So trigonometry allows us to calculate and find missing angles and sides in a right angle triangle. But first, before we can do that, we need to be able to label the sides of a triangle. Let me just draw a right angle triangle here. This won't be perfect. Let's just say this is our right angle triangle here, like so. And let's say we've got this angle here, which is x. Okay. So the easiest side to identify here is the hypotenuse, which you should be familiar with from Pythagoras. And that's the side that's opposite the right angle here. So let me just do this in a different color here. Let's do it in orange. So this length here is what we call the hypotenuse. Okay, this is the hypotenuse. And this is always the longest side in a right angle triangle. We normally just shorten the hypotenuse here to h. The next easiest side now to identify here is the side that's opposite the angle that we're given. So this side here, opposite the angle we're given, this is what we call the opposite. This is the opposite here, which we normally just shorten to O. That's this length here. Okay, that length there. And then finally for this base length here, well, that's just our remaining side, which is what we call the adjacent. So this here is the adjacent, which we normally just shorten here to A. Okay, so we've got the hypotenuse, the opposite, and the adjacent. And there's three ratios that you need to be able to remember for trigonometry. So if I just go back to my original pen color now, the first of these ratios here is for what we call sine. And to shorten this here, we normally just write this as sin, sin or sine. We've then got cosine, which we normally just shorten to cos. And then finally we've got tangent here, which we just shorten to tan. Okay, and we can calculate these ratios by calculating the ratio of two sides of a right angle triangle. And to do this, we can use something called SOHCAHTOA. So let's write this underneath here. So SOHCAHTOA allows us to easily identify the ratios here. So sometimes you might see this given as, so the S with the O over the H here, like so. So that's the SO part there. We then got the C here with the adjacent above the hypotenuse. And then finally the tangent here, T, with the opposite over the adjacent. And that's now because this allows us to identify the ratio. So for sine x then, so for sine x here, that's going to be the opposite over the hypotenuse. So that's the opposite over the hypotenuse here. Or you can shorten that here as O over H. Then for cosine x here, or cos x, what we've got then is the adjacent divided by the hypotenuse. So that's going to be the adjacent like we said, that's divided out by the hypotenuse here. Which we can write as A over H. And then finally, for tan x here, then this is given as the opposite divided by the adjacent. That's the opposite divided by the adjacent. And again, we can shorten that here, so that's O over A. Okay. And there we have it. So that's everything that we need there now for our introduction here to trigonometry and SOHCAHTOA. So it is key that you can remember SOHCAHTOA here. Whether you remember that just literally as SOHCAHTOA, remember it in this form here as S with the O over the H, C with the A over the H, and then T with the O over the A like that. Doesn't matter which way you remember that. The way I like to personally remember it is the SOHCAHTOA way here. And then whichever letter comes first goes as the numerator here. So because O comes first, that's the numerator. H is second, so that's the denominator here. Same for cosine and tangent. Okay. So that's everything like we said then for the introduction here to trigonometry and SOHCAHTOA. So what we're going to do now is just take a look at two practice questions here. One question where we're going to find a missing side length, and then one question where we're going to take a look at finding a missing angle. Starting off with question 1 here then, where we've been given this right angle triangle and we're asked to find the value of x, given our solution to 2 decimal places. So to begin with here, we need to label this right angle triangle before we can do any trigonometry. So this length here, opposite my right angle, this is always the longest side in a right angle triangle. That would be the hypotenuse, so we'll label that as h. This base here now at the bottom, that's opposite this angle here that we've been given. That would make that the opposite, so we'll label that as O. And then finally, this length here must be the adjacent. Now remember, we only need 2 of these sides here, so which one of these sides do we not need? Well, we don't need the hypotenuse here. We haven't been given any length there. We'll get rid of the hypotenuse there. So now, using SOHCAHTOA here, SOHCAHTOA, I've got the opposite here and the adjacent. It won't be sine because we need the opposite and the hypotenuse, so it's not so or sine. It won't be cosine here because we've got the adjacent, but we don't have the hypotenuse here. In that case then, we're using tan here because we've got the opposite and the adjacent. We're going to use tan here. We do tan of this angle here. Okay, that's the angle that we're working with for this question. It's going to be tan of 50 degrees. And that's going to be equal now to some ratio here. So for the ratio, remember, it's going to be the first letter here as my numerator. So the opposite here will be my numerator, which is x in this case. It's going to be x over the adjacent here, which is 8. So now we just want to find x here. So basically, we're just rearranging here and making x the subject. In that case here then, using inverse operations, we're now going to times both sides here by 8. We'll times both sides here by 8. And in that case then, on the left hand side here, we'd get 8 tan 50 or 8 times tan 50. They're both the same thing, but normally we'd just write that as 8 tan 50 here. Okay, and that's going to be equal to x there. So now to find x here, you just need to put this into your calculator here. So therefore, x is going to be equal here to 8 tan 50. Like I said, just put that into your calculator here. But just be careful, obviously, that you give your solution here the correct degree of accuracy. In this case, 2 decimal places. So my solution here for x is going to be 9.53. Okay, working in centimeters here, so 9.53 centimeters there. I just place the units on as well. Okay, and there we have it. So that's the solution there to question 1. And finally then, if we take a look here at the very last question, question 2, where we've been given this right angle triangle, and this time now we're looking to find the size of an angle. So it says find the size of the angle marked x, giving your solution to 2 decimal places. So just like we started here with the previous question, let's just begin now by labeling this right angle triangle. So this length here opposite my right angle, that's always going to be the hypotenuse here, so we label that as h. This side here now, opposite the angle that we've been given, that would be the opposite, so let's label that as O. And then finally, this base here, this length at the bottom, that must be the adjacent. Now, in this case here, do remember that we only need 2 of these sides, so which side do we not need here? Well, we don't need the adjacent because we don't know anything about the adjacent here. So in that case then, we've got the opposite, we've got the hypotenuse, so now let's use SOHCAHTOA. So using SOHCAHTOA here, are we using sine, cosine, or tangent here for this question? Well, in this case here, we're going to use sine. And the reason for that is because we've got the opposite here, we've got the hypotenuse, so we're using sine. We start off here with sine of the angle. In this case here, it's a letter rather than a number, but that doesn't matter. We've got sine of x here. That's going to be equal now to this ratio. So in this case here, because we're working with sine, it's going to be the opposite over the hypotenuse here. So it's going to be O, which is 5, over the hypotenuse here, which is 9. We get sine x equals 5 over 9. Now, we're just looking for x here, okay? So how do we go from sine x to just x? Well, we use the inverse of this trig function. So on your calculator, you'd have that button that says sine, okay? So let me just try and draw what it looks like kind of on my calculator here. Let's just say that's your button here that says sine on it. Now above in a different color, it's usually kind of like a yellow, orange, or red color. I'll do it in red here. What you'll normally have above this here is sine, with this little -1 like that. Okay, so on my calculator, what I've got to do here is press shift, and then I press the sine button. And that gives me the inverse here of sine. So if you take the inverse here of sine x, so sine inverse of sine x, that would just leave you with x. Okay, so we're just using inverse operations here. On both sides here, I'm now going to take sine inverse. So sine inverse here on both sides, like so. So now, like we said on the left hand side, this would just leave me with x. On the right hand side now, we take sine inverse of 5 over 9. So now all you need to do here is just put this into your calculator here. So sine inverse of 5 over 9 to 2 decimal places here, we get x equals 33.75 there. Okay, and there we have it. So that's the solution there to question 2. That brings the end of this video on an introduction to trigonometry and SOHCAHTOA.